as a way of summing up everything we've learned in chapter 3 so far, I wanted to do one kind of extended problem example for you guys to see. So here's the problem. I'll write it out and then I'll read it. The problem is this. We have three forces, force A, force B, and force C, on a motionless object with a mass of 8 kilograms. Force A is equal to, these are given as magnitudes and directions. Force A is 10 newtons at an angle of 60 degrees above the plus x direction. Force B is also 10 newtons of force, 60 degrees above the minus x direction. And our objective here is to find FC, the third of those forces. Okay, so we can start by drawing a free body diagram. Before we do that, we might want to have a little bit of a game plan. So we're trying to find force C. How can we possibly know what force C is if we only know these other two forces? Well, the important thing to notice in this problem statement is the word motionless, and that puts a constraint on FC relative to FA and FB. So if we know these, we know enough to find that third force. So that's the big picture of where we're going here. So let's start with a free body diagram. So we draw our object as a dot. We draw our forces on the object, and here we're going to translate those words into a picture. So force A is 60 degrees above the plus x direction. So this is the plus x direction. So 60 degrees above that looks like this. And this is force A, which is 10 newtons. Force B is also 10 newtons, but 60 degrees above the minus x direction. These plus and minus x's are not part of the diagram. They're just showing what these angles are. This is also 60 degrees. And we want to find what FC is. FC is an unknown force, so I don't really know what direction to draw it. We could probably guess that it's going to be down, just because maybe it's balancing out the other two or something. It doesn't really matter. We're gonna figure out what FC is. So maybe FC is down and to the right. I'm gonna put a question mark there. For unknown forces, you can put a question mark on your free body diagram. That's okay. All right, so we would like to find what FC is. This being a force problem, it's good to at least think about Newton's second law. So remember, the second law is the sum of the forces is equal to ma. And here, remember, this really is two equations. This is that equation for the x components, and that is this equation for the y components. So let's look at our x components. I'm going to mark up our free body diagram. So this is the complete free body diagram, and now I'm going to draw stuff on it to explain what's going on, but those aren't necessarily part of the final free body diagram or whatever. Okay. So my x components, well, force A is, to the right, it has an x component that looks like this, and a y component that looks like this. So this is ax, f, a, y. And force B also has x and y components. This is f, bx, and this is f, by. Force C, we don't really know. I mean, maybe it has components. We should at least allow for the possibility that it has components. So maybe there's some fcx and some fcy. But we will, we're trying to find what these components are, so we're not attached to the directions as we've drawn them. So now that I have this picture, a way of solving this hopefully forms in your head a little bit. So if we have this equation, let's just take the x direction of Newton's second law. So what do we get when we add up our force components? Well, we get fax and fbx and fcx. And over here, we get max, but remember at the very beginning, we said this object was motionless. So if an object is motionless, sitting there with no velocity and staying with no velocity, that means our acceleration has to be 0. So whatever the mass is times 0, that's going to be 0. So force AX plus force BX plus force CX have to be 0. And if we know FAX and FBX, then we can solve for FCX. So that is what we are about to do. Oh, and of course, we can do exactly the same thing in the y direction as well. All right, so I'll erase this, although we're just going to do that again in a second, because I want to write down what our components are. So FAX, that is adjacent to our 60 degrees, so that is going to be 10 newtons times the cosine of 60 degrees. The cosine of 60, of course, is 1/2, so this just gives me a force of 5 newtons. The x component of force B, well, it is also adjacent to 60 degrees. Doing this cosine will also give us 5 newtons. And now we have to remember this is pointing to the left, which is in the minus x direction, so this needs a minus sign. If we had been very careful, we would have done that step on force A also and said, oh, this is to the right, that's positive, I'm going to put a plus sign there to remind myself that I checked if it's positive or negative. Okay, so we have those components. And then FCX is what we're trying to find. So the sum of our forces in the x direction is 5 newtons plus FBX is minus 5 newtons plus whatever the x component of force C is, and this is equal to 0. Okay, well, 5 newtons plus minus 5 newtons is also 0, so that leaves us with FCX is equal to 0. The x component of this force is equal to 0, which means that force C is either pointing straight down or straight up. One probably could have guessed this because of the symmetry here. Both of these are 10 newtons. Both of them are in, symmetrically opposite directions or whatever, mirror flipped directions. So you are, so one would be correct in thinking that FC has to be pointing straight down or straight up because of that symmetry. So that is correct, but we can show that more formally with Newton's second law also. All right, so that's good. I'll write this result up here. The x component of FC equals 0. And now let's do the y direction. So that, of course, is now this equation. So the sum of our y components is FAY plus FBY plus FCY, and AY is also 0, so these three forces also have to sum together to be 0. We can find what these two are and solve for FCY again. So FAY is going to be, so that's opposite the 60 degrees, so that's going to be 10 newtons times the sine of 60. Oh, I guess I'll do it like before. So FAY is equal to 10 times the sine of 60, which is equal to 8.66 newtons. And it is in the up direction, so I'm going to put a plus sign there, so we get plus 8.66, and we were careful to check that. For force B, we get exactly the same thing. We still get 10 times the sine of 60 degrees, and it is also up. So again, we get plus 8.66 newtons. These are both in the same direction. Remember, the x's were in opposite directions, so we got a minus sign. The y's are both in the same direction. So now when I look at the sum of our forces in the y direction, I get 8.66 plus 8.66 plus FCY is equal to 0. So now I'm going to get an answer that's not 0. Let's erase this and work over here. So 8.66 plus 8.66 is 17.3. We'll round that to 17.3. So 17.3 plus FCY is equal to 0. And solving for FCY, I get minus 17.3. So our y component of force C is 17.3 newtons, and it is down. So Fc is indeed in the straight down direction, like some of you probably guessed. So these two combined are our complete answer. The two x and the two components of Fc. We could also give this as a magnitude and a direction. So one other answer would be, Fc equals 17.3 newtons in the minus y direction. This is also another complete way of describing force C. All right, well, hopefully this example was helpful. I wouldn't rely too much on your intuition about what direction forces should be in, unknown forces. It is going to be safer to assume you don't know and do all the components out and find them. And if you're right and it is in the straight down direction or something, that's great, but maybe don't start by assuming that until you have more experience with forces.